Hey guys, welcome back to General Chemistry. In the last video, we talked about ionic bonds and how they form, why they form. So the whole purpose of the exercise is stability. Somebody gives up an electron, somebody takes an electron, we're charged, we're attracted, all those things. Now I want to talk a little bit more about how you can predict this. So I told you sodium does this and chlorine does that. Now I want you to be able to predict it. So this is all hinges on something I've mentioned before, and that is valence electrons. So for our main group elements, let's start there. Remember, we can predict valence electrons by the number at the top of the family. So these guys right here will have one valence electron. These guys will have 2, 3, 4, 5, 6, 7, and 8. So first and foremost, we need to be able to predict how many valence electrons they have before we can start to predict what they're going to do with them. And then remember, these guys right here are noble gases. They have 8 valence electrons, and they are particularly stable. Everybody's trying to get to 8 valence electrons. So predictions. This table will tell you exactly what each of the main group elements ions form, but I don't like to memorize anything in chemistry. I like to know the why and the how do I determine this information. So let's talk about chlorine and all of the guys in his family. So all of these you'll notice are the same. Remember, chlorine has 7 valence electrons. With the 7 valence electrons, chlorine is so very close to being like the noble gases. And so chlorine and all of his family will go out and they will steal 1 electron. When they steal that 1 electron, their electron configuration then looks like that of a noble gas. Their valence shell is full and they are happy. That stealing of an electron, and I did the math for this on the previous video, but stealing that electron will give them a negative charge. They stole 1 electron, so they have a -1 charge. And we typically depict this as a exponent with a negative sign. Okay. Now, let's go to oxygen here. How many valence electrons does oxygen have? 6, right? That's the number at the top. So oxygen has 6 valence electrons. He wants 8. So he's going to go out and he's also going to start stealing. But will stealing 1 electron help him? No. If he steals 1 electron, then he becomes like fluorine. Fluorine doesn't even want to be like fluorine. So stealing 1 electron is not going to be helpful. So when oxygen forms an ion, he's going to go out and he's going to steal 2 electrons. So we have 6 valence electrons, steal 1, steal 2. Now our valence shell is full and our electron configuration looks like that of a noble gas. Stealing 2 electrons is going to be the same as putting 2 negatively charged particles into our valence shell. So we're going to have a -2 charge. Back up one more to nitrogen and everybody in nitrogen's family. And these guys have 5 valence electrons. They want 8, so they're going to steal 1, 2, 3. So the silly way that I remember that when they steal an electron, they get a negative charge. You could do the math every single time. I have kind of a silly way to remember this. So stealing is bad, right? If you steal, you get in trouble. That's not a good thing. That's a negative thing. And so when we steal electrons, that's where we get these negative signs. Okay. Let's go to the other side of the periodic table. Let's go over here to sodium. So remember, sodium has 1 valence electron. That 1 valence electron does not make him stable. He's got a choice. He can steal 7 electrons to come all the way across the periodic table to be like the noble gas. Man, that's a lot of work. So sodium says, you know what? the nearest noble gas is actually behind me, right? So just like in an airplane, find the nearest emergency exit. It could be in front of you. It could be behind you. Find the nearest noble gas. Could be in front of you. Could be behind you. In this case, it's behind him. So sodium's like, you know what? I'm going to get slick. I'm going to give away my 1 valence electron. Here you go. Somebody take it. When he does that, he goes down in energy level, but that energy level is full and it is stable. So giving it away an electron for him is very useful. So this whole family will give away 1 electron when they become an ion. And so that's why they all have a positive 1 charge. Here's the silly way to remember that. Giving is good. Giving is a positive thing. We get a positive charge. Go here to family number 2. So 2 here, we've got 2 valence electrons. We could steal 6 or we could give away 2. And that's exactly what this family does, is they give away their 2 electrons. So they have a 2 positive. Jump across transitions because they're weird. And over here to 3. This is the one that gets you guys. This is the one that's trickier. So these guys have 3 valence electrons. And I think it's because they're over that gap that they kind of get confused. They have 3 valence electrons. So we still want 8. That's still the magic number. So I could steal 5. 1, 2, 3, 4, 5. Or I could give away 3. 1, 2, 3. And giving 3 away is easier than stealing 5. So these guys will also give away electrons. They give away 3 specifically. That gives them a positive 3 charge. One other thing to denote here is the way that we write the charges. So, of course, we write them as exponents. And then typically we write the magnitude of the charge and then the sign. So this one we would say 3 plus. It's not conventional to write plus 3. So typically in chemistry, we write 3 plus. So now you have all the tools that you need to correctly predict what type of ion is going to form. And this is going to be so incredibly important when we start to make compounds with these ionic compounds. Okay, just another valence trend slide, and that's it. I hope you guys found this helpful.